to El Economista Camuflado. In this tutorial, we are going to start a course on treatment effects. So in this tutorial, what I'm going to do is to set the stage for the material to come, introducing the fundamental problem of causal inference, which is the topic that we are going to talk about in this tutorial, and if everything goes well, in the tutorials to come. So in this tutorial, I'm just going to introduce the problem of causal inference. I will develop the notation that we are going to use later, and we will also review some important facts concerning random variables. First, let me try the board and it works. So, first of all, what is this tutorial about? Well, maybe you have asked yourself questions like this, like, will earning a master's in economics increase your lifetime earnings? Or does watching a specific TV channel cause people to vote for a specific political party? Or something like, will owning a dog increase your lifespan? Each of these questions concerns the causal effect of a treatment D on an outcome Y. Now, the terminology treatment evokes a medical trial, but we will use the term much more broadly to refer to any variable D whose causal effect we hope to learn. And that's the fundamental problem of causal inference. Okay? So, basically, what we want to understand is what is the effect of a treatment D on an outcome Y. For us, a treatment could be earning a master's, okay, earning a master's, or also watching a specific TV channel, or also owning a dog. And in this tutorial, we will focus on the case in which the treatment D is binary. It is either 0 or 1. So, if you have that D is equal to 1, here we are introducing some notation, we will say that you are treated. And if D is equal to 0, we will say that you are untreated. We will be particularly interested in methods for learning causal effects when the treatment variable is not randomly assigned, as could be the case in an observational rather than experimental study. So far as I know, no experiment has yet been carried out in which subjects are randomly compelled to be dog owners or forced to watch a specific TV channel. However, in economic research, there are studies that have been written and published that attempt to estimate the causal effect of both of these treatments. So in this tutorial, we will study methods and assumptions under which observational data can be used to recover causal effects. In these tutorials, we will also consider experiments in which subjects may fail to comply with their assigned treatments. In this case, the treatments that subjects actually receive are no longer randomly assigned, even if the treatments that they have been offered actually were. So, what's the fundamental problem of causal inference? So, I've just said that in causal inference, what we want to know is what is the effect of a treatment D on an outcome Y. And we are going to use observational data in order to learn about that causal effect. But now the fundamental problem of causal inference is that we can never observe a person's counterfactual outcome. We can never observe the counterfactual outcome. In other words, we can never know what her outcome would have been if her treatment had been different. For instance, after finishing, imagine that there's a student called Alice, and after finishing her undergraduate degree, Alice earned a master's in economics. Okay? So we have Alice, and she earned a master's in economics. Let's say that she now makes 70,000 euros per year. Would she still have earned as much if she had gone straight to work after finishing her undergraduate degree? So this is the counterfactual. What if instead of earning a master's degree, she went to work? What would have happened? Or let's put another example. Let's say that we have a person called Donald, and Donald watches, let's say, channel 10 hours a day, and this person always votes for candidate R. Now imagine that he hadn't watched channel 10. That's the counterfactual. What would have happened? Would he instead vote for candidate D? We don't know, because we cannot observe the counterfactual. So a counterfactual is a within-person comparison. It asks how a given person's outcome would have been different if her treatment had been different. Because we can never observe the same person in two different treatment states, we can never actually make this comparison. Now you may be wondering about a before and after comparison. Let me rewrite this. Before and after. For example, what if we looked at Alice's wage immediately before she earned the master's and then immediately afterwards? So we have the point in time at which Alice earns the master's, and then we can see her wage before and her wage after. Tracking the same person over time can be an extremely helpful way to untangle cause and effect. However, it cannot solve the fundamental problem of causal inference. Comparing Alice's wages at two different points in time across two parallel universes, one in which she went straight to work and another in which she went to do the master's in economics. Most people's income increases as they gain additional experience, for example. Then, comparing Alice's income before and after might confuse the effect of more experience in the labor force with the effect of earning a master's in economics. Or perhaps Alice started the master's during an economic boom and finished during a severe downturn. If so, the fact that her income fell after the master's would tell us little of value. Perhaps it would have fallen by more without the degree. Because the idealized within-person comparison is impossible, we will need to develop methods and assumptions that allow us to substitute a between-person comparison. And this is all for today. Thank you very much for being in the other side. See you next time!